Hello everyone, welcome to another math video. I'm Professor Diwa, and in this video I'll be going over graphing linear equations. The objectives are to plot ordered pairs on a rectangular coordinate system, determine whether an ordered pair of numbers is a solution of an equation in two variables, graph linear equations, graph vertical and horizontal lines. Alright, so let's get started. First, we're going to talk about the rectangular coordinate system. Here I have a graph which is intersected by a vertical and horizontal line going through the middle of the graph. The horizontal line is called the x-axis, and it's numbered from left to right. Starting on the left, we have -7, and it counts up by ones all the way up until we have +7. Now on the ends of the x-axis, we have little arrows, meaning that this graph doesn't stop at -7 or 7, it actually extends in both directions. The vertical line is called the y-axis, and it's numbered from bottom to top. Starting at the very bottom, we have -7, and we count upward by 1 until we get to +7. Just like the x-axis, the y-axis has arrows at the ends of the line. This indicates that the graph extends beyond the value of 7 and -7. The origin is a special point that lies at the very center of the graph, where the x and y axes intersect. The origin has an x and y coordinate given as parentheses 0, 0, close parentheses. This is also referred to as an ordered pair. The first 0 in the ordered pair refers to the x coordinate, and the second 0 in the ordered pair refers to the y coordinate. We use x and y coordinates to find the location of any point on a graph. For example, we have a red point in the top left corner of the graph. Let's say we didn't know where this point was, and all we're given was the ordered pair, or the x and y coordinates of -4, 2. To find the location of this point, we would start at the origin, and then from the origin, we would use the x coordinate to tell us how far we'd go to the left or right on the x-axis. We have an x-coordinate of -4, which means we'd go 4 spaces to the left. From that location, we would use the y-coordinate to tell us how far we need to travel up or down. The y-coordinate is 2, so from our current location, we would travel 2 spaces up, parallel with the y-axis, and that would be the location of our point. Next, I'd like you to notice that the graph is divided up into 4 equal spaces. These spaces are referred to as quadrants. In the top right corner, we have quadrant number 1. Every single point that lies inside of this quadrant has a positive x and y coordinate. The section in the top left corner is referred to as quadrant 2. Every single point inside of this quadrant has an x coordinate which is negative and a y coordinate that is positive. On the bottom left corner, this quadrant is referred to as quadrant number 3. Every point that's inside of this quadrant has an x and y coordinate that are both negative. Moving on to the bottom right corner, we have quadrant 4. Every point in this quadrant has a positive x coordinate and a negative y coordinate. For example number 1, they want us to plot the points A, B, C, D, E, and state their corresponding quadrants. For point A, they give us the coordinates of -4, 3. To locate this point, we start at the origin. From here, we use the x-coordinate of -4 to travel 4 spaces to the left. From our current location, we use the y-coordinate of 3 to travel 3 spaces up, and this is where we would plot our point A. They also want to know the corresponding quadrant. This quadrant is quadrant 2, so I indicated quadrant 2 by writing Q2 next to my point A. Next, we need to plot the point B. They give us the coordinates -5, -3. So starting at the origin, we go -5 spaces to the left. And then from this location, we'd use the y-coordinate of -3 to go 3 spaces down. So this is where we'd plot point B. And also this is in quadrant number 3. So I also wrote Q3 next to my point B. Next, we need to plot the point C. They give us the coordinates 0, 4. Starting at the origin, our x-coordinate is 0, so we don't move left or right. Our y-coordinate is 4, so we move 4 spaces up, and this is where we plot our point C. Notice here that the point C is halfway between quadrants number 1 and 2. When this happens, we don't write down that the point is in both quadrants. We simply state that it's on the y-axis. Next, we need to plot the point D. The coordinates are 4, -5. So starting at the origin, we would use the x-coordinate to travel 4 spaces to the right, and then the y-coordinate -5 tells us to go 5 spaces down. So this is where we would plot our point D. Also, this is quadrant number 4, so I wrote down Q4 next to my point. Next, we need to plot the point E, which has the coordinates 2.5, 0. So we start at the origin, and then we move 2.5 spaces to the right. And then from here, the y-coordinate is 0, so we go ahead and plot our point right here. So this is my point E, and also you can see that my point is halfway between quadrant 1 and quadrant 4. Just like for point C, we don't state that it's in both quadrants, we just state which axis it's on. So for point E, we write down x-axis. Moving on to example number 2, determine whether the ordered pairs 0, -12, 1, 9, and 2, -6 are solutions of the equation 3x minus y equals 12. To determine whether an ordered pair is a solution to an equation, we just need to substitute the values of the x and y coordinates in for the x and y variable in the equation. From there, we would simplify and see whether or not we get a true or false statement. First, we're going to start with the ordered pair 0, 12, and we take our equation 3x minus y equals 12 and substitute in the value of 0 in for x and 12 in for y. We get 3 times 0 minus 12 equals 12. Simplifying the equation, we get 0 minus 12 equals 12. So from here, you could see that -12 is not equal to 12. This means that the ordered pair 0, 12 is not a solution to the equation. Moving on to the ordered pair 1, 9, we substitute in the value of 1 in for x and 9 in for y into our equation. We get 3 times 1 minus 9 equals 12. Simplifying this equation, we get 3 minus 9 equals 12. Simplifying further, we get -6 equals 12. Since -6 is not equal to 12, this is false, and that means that the ordered pair 1, 9 is not a solution to the equation. Next, we check our last ordered pair, 2, -6. We plug in 2 in for x and -6 in for y in our equation. We get 3 times 2 minus parentheses -6, close parentheses, equals 12. Simplifying this equation, we get 6 plus 6 equals 12. Simplifying further, we get 12 equals 12. This is true, so that means that our ordered pair 2, -6 is a solution to this equation. Next, we'll go over the standard form equation of a line and the slope-intercept form of the equation of a line. The standard form equation of a line is written as capital A x plus capital B y equals capital C. An equation written in this format can have its pros and cons depending on what we need it to do. If we're trying to find the x and y-intercept of a line, then this would be a good format to use. Next, we have the slope-intercept form of the equation of a line. It's written as y equals mx plus b, where m is the slope of the line and b is the value of the y-intercept. Be really careful because many students mistakenly call b the y-intercept, but specifically it's the y value of the y-intercept. The y-intercept is where the line intersects the y-axis and should be given as an ordered pair. So here you can see the y-intercept is written as parentheses 0, b, close parentheses. Next, we have example number 3, where we're going to graph the following equations using the point plotting method. For part A, we have the equation y equals 1/2 x. The first thing we're going to do is make an xy table, and we're going to pick 3 values for x. It could be any values that you want to use. I recommend picking values of x that make your calculations easy. For my x values, I chose to use 0, 2, and 4. From here, we need to find the corresponding y values by taking each of the x values and substituting them in for x into our equation. Starting with 0, I have y equals 1/2 times 0. 1/2 times 0 is just 0, so the corresponding y value that goes in our table would be 0. Next, we have our x value of 2, so we plug that into our equation. We have y equals 1/2 times 2. Simplifying that, we get that this is equal to 2 over 2, or just 1. So the corresponding y value that goes in our table is 1. Next, we have the x value of 4, so we plug that into our equation. We get y equals 1/2 times 4. Simplifying this, we get 4 over 2, which is equal to 2. So the corresponding y value in our table will be 2. Now that our table is complete, each of these pairs of x and y values represents an ordered pair, or a point that we could plot on our graph. So we have the ordered pair of 0, 0, we have 2, 1, and 4, 2. Next, we could plot these points on our graph, and then we could go ahead and draw our line. Here I have a graph where I numbered each of the spacings on the x and y axis, starting with -7 all the way up to +7. Here I plotted my first point 0, 0, my second point 2, 1 is here, and I plotted my third point 4, 2 right here. Next, we draw a line going through all 3 points, and at the end of the line, you want to make sure you add arrows. The arrows indicate that your line doesn't stop at the end, but keeps on going in both directions. When you're graphing a line, if you're not able to draw a straight line through all 3 of your points, then that indicates that you made a mistake somewhere. You would just need to go back and double check all of your work. If we take a look at the original equation, we could see that it's written in slope-intercept form, which is y equals mx plus b. Our m value would be 1/2. Our b value, notice there's nothing written there. That indicates that our b value is 0. So our y-intercept is 0, 0. And you could take a look at our graph. You could see that we have a point at 0, 0, and our line intersects the y-axis there. So that's correct. We could also use the slope. Our slope is 1/2. The number in the numerator represents our rise, and the number on the denominator represents our run. So if we start at our first point 0, 0, we'd use the rise to tell us how far up or down we would go from this point. So I'm going to go up 1. And then from here, we'd use the run to tell us how far left and right we would go from this location. So the run is 2, so we go 2 spaces to the right. And notice here, I'm back on the line. If we use the slope again, we'd go up 1 and over 2, and we're back on the line at our third point. So this would be another way that you could verify to ensure that everything is correct for your graph. Moving on to part B, we have the equation y equals -2x plus 3. Again, we start with an xy table, and you could choose any 3 values for x. I chose to use the same values of 0, 2, and 4. Next, we find the corresponding y values by taking each x value and plugging it into the equation for x. Starting with x equals 0, we get y equals -2 times 0 plus 3. This simplifies to 0 plus 3, which equals 3. So the corresponding y value in our table is 3. Next, we have the x value of 2. So we get y equals -2 times 2 plus 3. This simplifies to -4 plus 3, which is equal to -1. So the corresponding y value is -1. Next, we have x equals 4. So we get y equals -2 times 4 plus 3. This is equal to -8 plus 3, which simplifies to just -5. So the corresponding y value would be -5. This gives us 3 ordered pairs. We have 0, 3, 2, -1, 4, -5. Next, we can plot our 3 points on our graph. On my graph, I labeled each of the spacings on the x and y axis, starting from -7 to +7. My first point, 0, 3, is right here. My second point, 2, -1, is plotted right here. And my third point, 4, -5, is plotted right here. Next, we draw a line going through our 3 points, and we add arrows to the ends of our line. Next, we can verify that our graph is correct. The slope for this equation is -2, or you could even write this as -2/1. Starting at our first point, 0, 3, we go down 2 spaces and over 1. This puts us back on the line. From here, if we go down 2 spaces and over 1, we're at our second point, 2, -1. We use the slope again. We go down 2 spaces and over 1, we're back on the line, and then go down 2 spaces over 1, and we're at our third point, 4, -5. So everything is correct here. Next, we have a practice problem for you to try. For part A, we have the equation y equals -3/2x, and for part B, we have y equals 4x - 3. So go ahead and pause the video, graph each of the equations, and then check back with the video to see the solutions. Alright, so let's get started with part A. For part A, I made my xy table, starting with the x values of 0, 2, and 4. Plugging in the value of x equals 0 into the equation, we get y equals -3/2 times 0 is equal to 0. Next, we plug in the value of x equals 2. We get y equals -3/2 times 2 equals -3. Finally, we have x equals 4. Plugging that into the equation, we get y equals -3/2 times 4 equals -6. So now we have our ordered pairs of 0, 0, 2, -3, and 4, -6. Next, we could go ahead and plot our points and graph our line. So here's the graph of our line going through our 3 points 0, 0, 2, -3, and 4, -6. Moving on to part B, I chose the x values of 0, 1, and 2 for my xy table. Starting with the x value of 0, we plug that into our equation. We get y equals 4 times 0 minus 3. This equals 0 minus 3, which equals -3. Next, we have x equals 1. When we plug that into our equation, we get y equals 4 times 1 minus 3 equals 4 minus 3, which is equal to 1. Finally, we plug in x equals 2. We get y equals 4 times 2 minus 3 equals 8 minus 3, which is equal to 5. So our corresponding ordered pairs are 0, -3, 1, 1, and 2, 5. So here's the graph of our line going through the points 0, -3, 1, 1, and 2, 5. Next, we will go over how to find intercepts. To find the x-intercept, let y equal 0 and solve for x. To find the y-intercept, let x equal 0 and solve for y. In the next example, I'll show you how to use this information to find the x and y-intercept. Here we have example number 4. Find the intercepts and graph the equation 3x plus 4y equals -12. To find the y-intercept, we first plug in 0 for x and then solve for y. So substituting in 0 for x in the equation, we get 3 times 0 plus 4y equals -12. The 3 times 0 gives us 0, so we're left with 4y equals -12. From here, we solve for y by dividing both sides by 4. We get 4y divided by 4 equals -12 divided by 4. Simplifying the left-hand side, 4y divided by 4 is y. Simplifying the right-hand side, -12 divided by 4 is -3. So we get y equals -3. This is going to be the y value of our y-intercept. We write our y-intercept as parentheses 0, -3, close parentheses. Next, we're going to find the x-intercept. So for the x-intercept, we plug in 0 for y, and then we solve for x. Plugging in 0 for y in our equation, we get 3x plus 4 times 0 equals -12. The 4 times 0 is 0, so we're left with 3x equals -12. From here, we need to solve for x by dividing both sides by 3. We get 3x divided by 3 equals -12 divided by 3. Simplifying the left-hand side, 3x divided by 3 is just x. And on the right-hand side, negative 12 divided by 3 is negative 4. So we get x is equal to negative 4. The x-intercept is written as parentheses negative 4 comma 0. Next, we go ahead and plot our x and y-intercept on our graph. So I have my y-intercept 0 comma negative 3 plotted here, and my x-intercept negative 4 comma 0 is here. And then finally, we go ahead and draw a straight line through those 2 points. Next, we have another practice problem for you to try. Find the intercepts and graph the equation negative 2x plus 3y equals negative 6. So go ahead and pause the video, try out this problem, and then check back with the video to see how you did. Alright, so let's get started. To find the y-intercept, we just plug in 0 for x and then solve for y. When we plug in 0 for x, we get negative 2 times 0 plus 3y equals negative 6. The negative 2 times 0 cancels out, and we're left with the 3y equals negative 6. To solve for y, we just divide both sides by 3. We get 3y divided by 3 equals negative 6 divided by 3. Simplifying this equation, we get y equals negative 2. So our y-intercept is written as parentheses 0 comma negative 2 close parentheses. Next, we need to find the x-intercept by plugging in 0 for y and then solving for x. We get negative 2x plus 3 times 0 equals negative 6. The 3 times 0 cancels out, and we're left with the negative 2x equals negative 6. From here, we solve for x by dividing both sides by negative 2. We get negative 2x divided by 2 equals negative 6 divided by negative 2. Simplifying this equation, the result is x equals 3. We write out our x-intercept as parentheses 3 comma 0 close parentheses. Next, we plot the x and y-intercept. So on my graph here, I have my y-intercept of 0 comma negative 2 here, and then my x-intercept 3 comma 0 would be here, and then I have my line going through those 2 points. Moving on to example number 5, part A, we need to graph the equation x equals 6. To graph this equation, we're going to use the point plotting method. So here I have my xy table. Typically, we would choose the first 3 x values. However, because we have the equation x equals 6, the x value is a constant 6. In that case, the 3 values of x we're going to use are all going to be 6. For the y values, you could choose any value you like. However, I chose -1, 0, and 2. Now when I graph the line, you'll see why the y values don't matter. So we need to graph 3 ordered pairs, 6 comma -1, 6 comma 0, and 6 comma 2. Over here I graph 6 comma -1, here I have 6 comma 0, and over here I have 6 comma 2. Drawing a straight line through these 3 points results in a vertical line. You can see here that a vertical line uses all of the y values on the y-axis. This is the reason why we were able to choose any y value when we were creating our x and y table. Note that this only applies when you're graphing a vertical line. Moving on to part B, we need to graph the equation y equals 5. Again, we're going to use the point plotting method. We can choose to use any 3 x values for our x and y table. However, I chose to use 0, 1, and 5. Now for the y values, notice in our equation, y is equal to 5. This means that y is going to be 5 for any value of x that you choose. So we're going to use 5 for all 3 values in the y column. This results in 3 ordered pairs. We have 0, 5, 1, 5, and 5, 5. So now let's graph the 3 points. We have 0, 5 here, 1, 5 over here, and 5, 5 over here. Drawing a straight line through all 3 points results in a horizontal line. Next, we're going to go over the properties of graphing vertical and horizontal lines. Here it states the graph of x equals c, where c is a real number, is a vertical line with the x-intercept of parentheses c, 0, close parentheses. Next, it states, the graph of y equals c, where c is a real number, is a horizontal line, with the y-intercept of parentheses 0, c, close parentheses. If we take a look at the graph from example 5 part A, you can see we have a vertical line. The equation for this vertical line was x equals 6, so this means that our x-intercept would be at 6, 0, and you can see on our graph we have our x-intercept at that point. If we take a look at example 5 part B, we have the graph of a horizontal line. The equation was y equals 5. This means that the horizontal line has a y-intercept of parentheses 0, 5, which we could see right here. It's common to see students mix up the graph or the equation for a horizontal and vertical line. If you ever get mixed up, you could always use the point plotting method to figure out which one is which. Alright, so this is the end of our video. I'm Professor Diwa. Thank you very much for watching, and I'll see you in the next one.